Chapter 2, the metric system. The basic unit system for, the official unit system for science is the SI system. That's for the French, I'm not even going to try to pronounce that, the International System of Units. And these are the official base units for the SI system. The SI system is based on the metric system. Now, chemists use the metric system, which is just so close to the SI system that I don't think it's really worth discussing the differences, except to tell you they are not exactly the same. The differences are very subtle. So we're just going to focus on the metric system. You're probably familiar with the English system. It's named the English system because it was primarily used in the British Empire. It wasn't very standardized. A span was a unit that was 4 fingers wide. Well, that kind of depends on how big your fingers are, right? And so in 1790, the French organized a committee to standardize and create a universal measuring system. And that's where the metric system came about. And the metric system really is a much better system than the English system. It's very simple. There's a single base unit for each measurement, and we use prefixes to change the sizes. So here are the basic units for the metric system. Length is measured in meters, mass is measured in grams, volume in liters, and time in seconds. The original definitions used for the metric system are kind of interesting. A meter was defined as 1/10,000,000th of the distance from the North Pole to the equator. Kind of interesting. When you define units, you have to define them in a way that other people could reproduce your definition. A kilogram of mass is equal to the mass of a cube of water measuring 0.1 meters on each side. So that's 1,000 grams was a cube of water. They based it on the water. And then they said that a liter was equal to the volume of 1 kilogram of water at 4 degrees Celsius. So those were the original definitions. The current definitions are much fancier. And I'm not going to test you on those. I just think it's interesting to see how those units were defined. A big advantage of the metric system is that it is decimal. It's based on powers of 10. So instead of having different units, like kitchen measuring units for volume, you've got teaspoons and tablespoons and cups and pints and quarts and gallons. And the relationships between them are all different, right? There's 3 teaspoons and a tablespoon. And I cannot for the life of me remember how many tablespoons are in a cup. I just can't. It has something to do with 4. It's 16 or something. 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Where do these numbers come from, right? They're all different. There's 12 inches in a foot, 5,280 feet in a mile. They're just random because they are random. The units were fairly randomly established. The metric system, though, everything is based on powers of 10. So if we have a kilogram, the prefix kilo means 10 to the third or 1,000. So a kilometer is 1,000 meters. Milli means 1/1000th. So a millimeter is 1/1000th of a meter. We need different unit sizes because if you measure something very small, you want to use a unit that is close to the size of that object. If I was going to measure the length of this stylus, what English unit would I use? Inches, right? I would not want to measure this in miles. That would be ridiculous. I live in Reedley. I would not want to measure the distance between my house and my office in inches, right? It's going to be some crazy huge number, and it's not really going to give me an idea of distance. I'd want to measure it in a large unit like miles. So we need units that are of different sizes, but instead of having random relations between them, they're all factors of 10. So this is the table of metric prefixes. Let me get my marker going here. And the iPad is not talking to me. Okay, now we're getting better here. So some of these are more important than others. So kilo is very important in chemistry, and centi, and milli, and micro. Those are probably the 4 most important ones for chemistry. These units apply to any of the basic units, meter, gram, liter, second. You can put these units in front of them. So here we have the prefix name, and each of them has a 1-letter symbol. You'll notice some of the big units, big prefixes, like tera multiplies it by 10 to the 12th. That's a huge number. These are capital letters, and these other ones are small letters. Another thing to notice is there's 3 prefixes that start with M. There's mega, and milli, and micro. So mega means a million of something, and so that's the capital M. The big M for the big prefix. And then there's milli. Milli is 1/1000th. Milli has the small m for the small prefix. But then there's also micro. And good grief, what happened on this table? That's not supposed to be there. It's the Greek letter mu, because we ran out of English M's, so we turn to the Greek alphabet when we need more letters. So mu is the symbol for micro. I think there was an error in the table, because I'm pretty sure that's supposed to be micro there, not M with an asterisk. I think it's supposed to be micro, mu with an asterisk. So you'll be referring to this table frequently, and I think the most useful part is this part right here, the 10 to the something. If you look at these exponents, most of them are factors of 3. These go up 3, 6, 9, 12. Here we've got -1 and -2. Those are right there in the middle. And then the rest of these are 3, 6, 9, 12 again. There are other metric prefixes in between many of these, but we don't encounter them very much, so they didn't put them in the table. But the ones that I underlined, you definitely need to memorize. You should just know that kilo means 10 to the 3rd, and micro means 10 to the -6. We're going to be using them a lot, so hopefully that will help you to remember them. So we just looked at the table. They have symbols, and so we just put the prefix in front of the unit, so nanometer. And the abbreviation for that is the symbol for the prefix. Nano is N, M for meter. Microgram is mu G for microgram. This is deciliter, gigasecond. The capitalization is important. A millimeter and a megameter are not the same thing. So we have to be careful with our capital letters. Any questions about the metric prefixes? We'll use them a little bit today, but any questions right now? No. You guys are going to talk to me today, aren't you? You were great last week. It's like, yeah, I feel like they're alive. So far, not so great, but we haven't really done anything interesting either.